again, and welcome Pharmaceutical Calculations with Dr. Dave. Today we're going to look at international system of units in this video. I want to go over something that I talked about in the beginning, in the intro, is that there are three things for the international system of units, the SI units, or the metric system, as most people refer to it as. There are three main categories that we are going to look at. So the measurement of length, or measurement length, we need to know something called the base unit, which is the meter. In weight, the base unit is the grams, and in volume, the base unit is liters. The reason why we call it a base unit is because we're going to be using that term and we're going to be transitioning them into different units associated with groups of 10. So what I mean by that is that we can have something called the meter, right? We can have something called the decimeter, centimeter, millimeter, which we know of. I can do grams. I can say I have a decigram, centigram, milligram, and I can do liters. I can have a deciliter, centiliter, milliliter, a microliter, a nanoliter. So these are the base units. This is what we're using here as the base unit. Now I put this little graph here with those common prefixes. There are more prefixes than what are in that graph, that little chart here. What I am trying to show you here, right, for this chart is the ones that are common in pharmacy and that we use primarily a lot in pharmacy calculations. So the ability for us to transition from, let's say, a milliliter to a liter, how do we go about doing that? If I show you graphically, so if you have the unit, so let's say the unit that we're looking at is volume, we know that that's liters, right? If I said I have 5 liters of something, how many milliliters is that, right? How many milliliters is that? I can move my decimal point over. This is 1, 2, 3, right? 3 points over, so I would take the number 5 and move my decimal point 1, 2, 3, and that would give me 5,000 milliliters. I can do the same thing going backwards. If I had some problem that said that I had 5,000 milliliters, how many liters is that? I would be moving back 1, 2, 3 units this way, moving 1, 2, 3 units that way, getting to liters. You will notice that in this chart I have 3 points where there's not a solid line, it's a hashed line. That means that this is actually 3, so I call it times 3. This is 3 decimal points, so that line stands for 3 decimal points. So if I had something that was, let's say, an example here, keeping with the liters, if I had 0.4 milliliters, how many microliters is that? I would be moving my decimal point 1, 2, 3 points over, because this is 3. So I'm moving it over 3 points. So 1, 2, 3, and I would get 400 microliters, right? Or some people might call it microliters. If I wanted to go nano, I would go 3 over. So we do this a lot also in weight in pharmacy. So grams, we would have the unit here, the base unit here, instead of liters, it would be grams. And we might say we have 1 milligram of something. How many micrograms is that, right? And that would be 1,000 micrograms. How many nanograms is that? Or how many grams is that, moving back this way? So that's that chart there. You can do it mathematically, you can do it by the chart, but the ability for you to do it quickly is probably the best, so whatever works best for you. Visually showing you that you have the units and where they stand. I'm just going to erase this so that I can put something more in here, so that you know that you have your deci, centi, milli, then it goes micro, nano, and going to the left for bigger, 3 units over would be the kilo. So kilograms, grams, decigram, centigram, milligram, micro, nanograms. Same thing for liters or length for meters. Now, we don't do a lot of length measurements in pharmacy, but we do use it for surface area of patients, which is one example of where we have the meters or centimeters, right? Squared centimeters and square meters for surface area. Sometimes we use it for transdermal patches, so the patches that are actually put onto somebody, the area that those patches take up can be doing it. And sometimes for patient demographics, so we might give them their height in meters, or sometimes in centimeters. So the other one that we do use commonly a lot is the measurement of volume. Right? So the volume is very common. We use it for liquids. We use it when we do concentration. As you see, we have concentrations in milligrams per ml, micrograms per ml. We're going to have a lot of different units. So for liquid, you should be, for this course, familiar with what a liter is. You should know what a deciliter is, a milliliter, and a microliter, particularly knowing what a milliliter and a liter is. Yeah. So in pharmacy, we talk about a unit of measurement for volume. We say 1 milliliter. A lot of people will also call that 1 cc, or 1 cubic centimeter. And the reason for that is that the volume of water that is taken up by that is 1 cubic centimeter. So 1 ml takes up 1 cubic centimeter in terms of its volume at room temperature. So some people will call it cc, some people will call it mLs. Don't get confused by that. All right? It's not a precise substitution, but the terminology that people do use in pharmacy is be the same. But usually the mLs is what you're going to see markings for, especially on volumetric apparatus. The SI units for weight, as we see, there are some drugs that are dosed by weight, so knowing a patient's weight and knowing how to get the drug dose calculated is important. So we do see weight. We also see it used when we're making compounded preparations. We do have to know the weights of ingredients, total weights, things like that that we'll see. So you should be familiar with those abbreviations for weight. We have the base unit being grams, but you have the kilograms, the milligrams, and micrograms. Very important for the course. Notice through the abbreviations that some people may use or textbooks may use as well. CG, microgram. So in pharmacy, right, there is one other concept that we are going to use with that mLs and cc's. We are going to say that 1 ml of water, this is only for water, 1 ml of water is approximately equal to 1 cubic centimeter of water, 1 cc, which is also equal to 1 gram in terms of its weight. So it's 1 cc, 1 ml, 1 gram when we talk about water. Really, we're looking at the weight. If I was encountering a situation in pharmacy where I weighed out a certain amount of water and it weighed 2.4 grams, I know that the volume at room temperature, so to speak, would be that same exact in volume, so it would be 2.4 mLs. So gram per weight for water is the same. Keep that in mind. That is a very important thing in pharmacy that we do utilize. And even for compounding, we'd use that as well. As I made mention before, that there's sometimes where you're moving the SI units from the same base unit but higher or lower denominations. All right. And it can be done in a few different ways. And I'll show you the few different ways. One of them is that you can do it by using ratio and proportions. You can do it by dimensional analysis over here. You can also do it just by simple moving the decimal point left to right. So I'll show you what I mean by those. If we were to take the first example here, it says to reduce or to change 4.25 kilograms to grams, right? So let's look at this. How do I change that from one to another? So yeah, I can do 4.25 kilograms, right? Kilograms. If I go up to my chart, if I swing back up to here to my chart, and I want to go from kilo, right? Kilo, which is the prefix, kilograms. I want to go from kilograms to grams. I'm moving from this direction here. I'm going to move my decimal point 3 places to the right. So what I would do is I would move this 3 places to the right. This is 1, this is 2, this is 3, right? So I would have 4,250 grams, right? Moving 3 to the right. I can also do this problem by doing dimensional analysis. I know that I have well, let me start it the way in which we did it here. You can draw your line, right? Unit path. We're going to want units in grams, and we're given 4.25 kilograms. So 4.25 kilograms, and I want to get that to grams. So I need to cancel out the kilograms. So I know 1 kilogram is equal to 1,000 grams. Right? Because of that, I can cancel out my kilograms. I'm left with the units in grams, and I get the same answer by multiplying 4.25 times 1,000. Right? So that gives me the same answer, 4,250 grams. I can also do it by ratio and proportions. I can say that I know that there is 1,000 grams in 1 kilogram. How many grams if I've got 4.25 kilograms? Again, it's the exact same thing I just did up here. The kilograms cancel out. And you're left with the same exact answer, 4,250 grams. So let's look at another one here. This microliters to liters, 1,227,000 microliters. How many liters is that? Well, I'm going to write that number down. 1,227,000. This is, microliters. Microliters. How many liters is that going to equal? Again, I can go up to my chart. I want to go from microliters, which is here. I need to go 3 over, right, because of the line, and then I need to go 1, 2, let me count that again. 3 over to here, and there's 1, 2, and then 3 over to there was my base units. In this case would be liters. So that's 3, 4, 5, 6. So I need to go 6 places to the left. So I would be moving my decimal point over 1, right? All right, 1, 2, 3, and then 4, 5, 6. So this would equal 1.227 liters is what I would get. Again, you can do a dimensional analysis, or you can do it by ratio proportions. The last one is 2.1 grams. How many mLs is this if I have this of water? Now this is H2O. So 2.1 grams of water is equal to 2.1 mLs. Now the question below here that I asked is, why is this the case, right? You can't convert grams to mLs and use the conversions that we just did. It's only the exception for water, because 1 gram of water is equal to 1 ml of water in terms of the volume it takes up approximately room temperature. So that's why. So you have to make sure that the units are the same when you're doing this. Only water is an exception to that. And even if you're doing fractions, you have to make sure the denominator is the same when you're doing that. All right. Let's look at this. What do I mean by that? Let's take an example. You've got 4 kilograms, 125 milligrams, and 2.5 grams. What is the total weight of that? So you have those 3 components. What is the total weight of that? You can't just add 4 plus 125 plus 2, right? All these units have to be the same here. All right. So let's take we would take the 4 kilograms, and I'm going to convert that to grams, and I'm going to say that's 4,000 grams. I'm going to take my 125 milligrams, and I'm going to move my decimal point over 3, and I'm going to take that as 0.125 grams. And my 2.5 grams, I'm going to keep as 2.5 grams, because that is what the units that I have everything in over here is in grams. So because all this is grams, I can add them together. If I add them together, I get that 4,000, looks like 2.625 grams, which is what I should get. So notice that the ability for us to switch between them is also important when we're going to be using them as an addition to subtraction or working with these numbers in units. Take a last example. We have a nurse telephones in a pharmacy regarding the proper quantity of an injection to administer to a pediatric patient from a 1 ml vial that contains 0.1 milligrams of digoxin. The attending physician has prescribed a dose of 25 micrograms. how many milliliters should the pharmacist respond to? So in other words, we have a nurse. She has a vial. I will attempt to draw a vial here. So she has a vial. So here's a vial of a medication. The medication is digoxin. And the strength on this is 0.1 milligrams per 1 ml. How do I know that? Because the question gave me that there is a 1 ml vial, which means it's got 1 ml liquid in it. And in that 1 ml liquid, it contains 0.1 milligrams of digoxin. The physician wrote that they want to give the patient 25 micrograms of the drug. How much of this liquid do you have to take away? How much do you have to draw up and inject into the patient so that you get 25 micrograms? If we gave them all of it, we'd be giving them 0.1 milligrams, right? We want 25 micrograms. So how much of that liquid do we need to do? This is where, again, you can do it different ways. I'm going to do mine just setting up as a ratio. I know what I have, a 1 ml vial, and it contains 0.1 milligrams per ml. And I need my answer to be in mLs. So I'm going to write the thing that's given to me, 1 ml, the mLs on the bottom to cancel out. And the unit I want, 0.1 milligrams on top. Now, I'm going to do a very quick conversion. I'm going to say that this 0.1 milligrams is how many micrograms? All right, so there's my decimal point, 1, 2, 3. Move it to the right, I've got 100. All right, so this is equal to 100 micrograms. So the question is going to be that in my ratio, I'm just going to write it so that I know that I've got 100 micrograms is in 1 ml. So instead of this label saying 0.1, the label is saying 100 micrograms per ml. How many mLs if I want 25 micrograms? Right? And I apologize that I wrote this the opposite way that I wanted, so please disregard that. What I'm looking for is the mLs, so I need to put the mLs on top. So I know that in 1 ml there is 100 micrograms of drug. I need 25 micrograms of drug that equals 0.25 mLs. This is what I would phone to the nurse. We would say you're going to withdraw from that vial 0.25 mLs. So 0.25 mLs. In that 0.25 mLs, you're going to get a dose of 25 micrograms. And that is what you're going to inject to the patient. Right? A lot of questions in pharmacy where we had given a concentration and we're given a dose, and we need to figure out how much to either withdraw, inject, dispense to the patient orally. So that's something to keep in mind, how we utilize not only what we just learned about doing racial proportions, but dimensional analysis, but also now using it with the units appropriately to answer pharmacy questions. All right, so that is pharmaceutical calculations. As always, pharmacy calculations is the most important class because it's the only one that counts.